Hi everyone, my name is Patrick Akio, and if you're interested in how things work on a technical level, as well as what does elegance mean when we're talking about programming, this episode is for you. Joining me today is Andrew Snare, consultant and software engineer over here at Xebia, and just an interesting mind and person to talk to. I'll put all his socials in the description below. Check him out, and with that being said, enjoy the episode.
Beyond coding.
I've always had an interest in how things work, and through my career, it's been useful to continuously make sure that you keep on top of how things work, and that gives you a framework when you come across new things of hanging them accurately in relation to the things that you already know.
Yeah.
And the biggest challenge I see in our industry, or when I'm working with colleagues and people, is that sometimes I can see a concept has been put in the wrong spot. And fixing that, or not fixing is the wrong word, but trying to communicate when people have different ideas of how things work is very, very difficult.
I can imagine.
That can be extremely challenging.
It's a difference in fundamental understanding then. If I think the world revolves around X and you think it differently, then you have an interesting discussion.
Well, it can also lead to misconceptions. The most common one I come across is time.
Yeah.
And in computers, how we deal with time zones. And time is completely independent of a time zone. It's this idea of an immutable clock that moves forward. Now is now, whether you're in Sydney or New York.
Yeah.
How we describe it and represent that time as humans, that involves a time zone. Because I can say it's 9 o'clock in Sydney, 2 o'clock in the morning in New York, or something like that. But that's where the time zone came in when I was trying to describe the moment in time. But computers don't need that. And what I often see is developers, for example, that's an example where they make mistakes of saying, well, what's the time zone? And I'm like, well, it doesn't matter because it's a timestamp and you don't always need a time zone attached to it until you log it or you need to display it.
Yeah, because then it's based on interpretation. You need to know in which time zone you're at to see when it happened.
Well, you need to see. You don't actually, but you need a reference to describe it to someone, and you don't always need to. So you don't always need a timestamp because you can just say, well, we're going to use seconds since 1970, in midnight 1970. I can describe a time to you in that way. There's no time zone involved, and you both have the same idea.
Yeah.
But when it comes to interpreting it for a user, that's often where the time zone starts to become important. Up to that moment, it's actually entirely unimportant. And this is an example of where I see people have a different way of thinking about things, and often it can be difficult where that's where communication becomes challenging.
I can imagine. Yeah. For me, it's always, I describe software engineering and it has depths in certain areas, right?
Yep.
And I always describe myself as someone that wants to know, let's say 70 or 80%. And for that last 20%, I rely on my team for that knowledge, right? It's easy because I like focusing on communication, making sure we do the right thing. All of the aspects around software engineering that is also needed when building a product, for example. But I don't know if I'm doing myself a disjustice for not going in that depth that I feel like you do. How have you seen kind of different teams revolve around that?
So it depends, because sometimes when I'm on a team, I'm the expert.
Yeah.
So you need to go beyond that 70 or 80% and make sure that you're at 99 point whatever. Because the problem with this knowledge is that it doesn't accumulate by the 70%. The bad things in software the bad things that we often associate with quality control and technical debt and so forth, they normally come around about because of the 5% that's been missed.
Yeah.
So I normally make sure I go quite high. But more important than knowing that last gap is being able to detect someone else that does or doesn't know it. So if I'm on a team and I don't have that 20 or 30%, I rely on what I do know to be able to, have what I call a bullshit detector.
Yeah. Very important.
And being able to detect this person does know that 30%, we're in good hands, versus this person thinks they do, but they don't. That's almost as important as knowing it yourself.
Yeah.
Knowing when you can actually trust your team around you to know it, and knowing when, hey, no, sorry, I've got to do the research myself.
Yeah.
And you can a good proxy for that is I find as a software engineer is how well you feel you need to review other people's code during code review.
Okay.
Because if you find yourself seeing code and you know instantly, I don't need to go into all the details, this is solid, then that means you're trusting that teammate and you know that they've got that gap all covered. If you find yourself saying, I've got to effectively pretend I'm rewriting this myself and go into every detail, then you know that you're that 99%.
Yeah. Have you found to be comfortable in that position, or over the years, how have you found kind of comfort there? Because I feel like for people starting out, to be the sole expert, to know that 99% and other people relying on you can be quite daunting there. Because if you make a mistake and no one else knows that last gap,
it can be stressful. Sometimes it's kind of cool.
Yeah, it is awesome.
Well, when it comes off, but at the end of the day, we're never going to have the 100.
Yeah.
So to a certain extent, you've got to stay humble in those situations and recognize that there's going to be mistakes no matter what. The other thing that's important is how you communicate in that situation. And sometimes you have team members that recognize that gap and they're like sponges. They want to learn. They've got the passion. They're like, that's fantastic. Hadn't thought of that. This is really great. Occasionally, you bump into the problem where so everyone thinks they're the world's best programmer. Everyone.
I don't think so.
I
don't think that's the case.
No. Everyone thinks they are. And often when people don't recognize that they've made a mistake or they're not used to it, then it can be challenging because it can sort of it can be quite confronting. We've got that challenge, I've had that challenge in the past.
I can imagine.
And that communication can be really, really difficult.
Yeah, I mean, it drills down into kind of that humbleness that you already mentioned. We're never at 100%, right?
No.
So if you realize that the knowledge, you're never going to be at 100%, then there will be mistakes in there. So you will be kind of that sponge person and be like, is that truly the case? And you're open for a discussion there without judgment, right?
Yep.
Because as soon as there's judgment, no, you're wrong, I'm right, then the discussion becomes very, very hard.
Yeah. And so indeed, definitely. There's one department in particular where I worked for a while, and that was fantastic because we'd make mistakes and there'd be people around you that would point things out, and I was like, I don't need to know all this stuff. And when I didn't, or if I made a mistake, it was just like, this is going to be it. And everyone just moved on straight away. Yeah. There was no discussion about it. Everyone just recognized instantly, this is the problem. This is how we're going to deal with it. We're not going to sit and discuss back and forth about why this is right or wrong. It was actually quite liberating. I really enjoyed that time.
What about that department made it that environment that you described, where it was kind of that openness and allowing for mistakes in that way?
It was partly openness. They were also, I think, the best quality people I've had the pleasure of working with.
Yeah.
It was it was really, really good, actually. I'm just going to leave it. So I've got to be a bit careful here about names.
Sure.
I can't identify too closely. But it was there was definitely a lack of ego, and it was people recognised how you can use it to build up, and not all teams realise that.
Interesting.
Not all teams realise how to build up on each other.
Did it come through? Because I'm still trying to figure out what ingredients were in there to make it that environment. Was it a certain level of expertise, discipline, humbleness is definitely there.
No, definitely. It was also a recognition that with software, especially if you want to have good quality software and reliable software, time is a bit fuzzy.
Yeah.
In terms of how long it takes to do something. Everyone recognized that. So in some ways it was a slow team, but when they did things, they were solid and they stayed good for much longer. And it was, and the reason for that is I think they also recognized that when you combine components, they all need to be bug-free. If you've got something which is 99% or 98%, one component 98% is okay, that's fine. But when I've got 2 or 3, then suddenly it's 90% once you accumulate. Those 2% are what accumulates, not the 98. And these people had been in situations where they'd seen teams that are spending all their time on operational issues dealing with bugs and with no time to move the product forward because of these issues, these 2% that accumulate. And so they recognised and spent a lot of effort on making sure that things are 99.9 or whatever. And that was wonderful to see.
I can imagine. But then you have to fully align with your business, and the business needs to be aware that this is kind of the way we're going, right? To really strive for that quality.
Absolutely. And this was a business that operated at scale. And at scale, these things matter. And maybe that was what was different between this and a lot of other teams. These were all people with experience operating at scale. Whereas if you're building an application that's only going to be used by 30 people in the back office or something like that, then that's a different sadly, that's a different conversation. Yeah.
It's interesting to me because at some point you will need to balance kind of speed of delivery versus the quality of your output, right? Ideally, you want the highest level of quality, but the business and probably versus the competitors, you want the quickest kind of time to market, time to deliver.
Yes, and that's a huge challenge, finding that balance there. But it's also the one thing where you've got that hockey stick curve of scale. Once you go over that elbow, it has to that conversation doesn't become a conversation because it all falls in a heap. If you haven't prioritized the quality at that point or having it scale reliably.
Exactly. That's the interesting part though, because everyone foresees kind of the hockey stick curve probably in what they're doing.
But a lot of people don't reach it.
No, exactly.
And that's the challenge I have.
Exactly. But even to build then your software or your product with that hockey stick curve in mind, to get to that point, you also need to kind of have kind of that flatter line in time, basically.
You do. And so someone with experience, so people with experience will recognize things, the low-hanging fruit. So during that flat bit where you're not scaling yet, there are often obvious things that you can do which will prevent you from unnecessarily making things bad. And that can be a difficult conversation because the people without experience don't recognize that always. And it's sometimes hard to get alignment there because they'll be like, why does this matter? I'm like, well, it can matter. And they're like, oh, that's just outside their experience. So that can be a bit of a challenge. But it's not just, so the hockey stick it doesn't always have to be people and users and stuff. Sometimes it can be revenue and money. So for example, I worked on an application which was being used by traders and we only had 30 users, but it had to this was being used by traders. And when I arrived on that team, I can talk about this because it was a bit longer ago, end to end for the information to arrive on their screens, there were 13 components between the data source and it arriving on their screen. And every one of those 13 components had to be working for it to end up. And when you look at that 99% sort of SLA, all of these components were fairly reliable, but none of them were 99.9 or whatever. They were all sort of 98, 99. And when you accumulate that over 13 components, it drops down super quickly. I don't know the curves off the top of my head. I have them saved as an image on my desktop because I refer to these all the time. But it drops down to like 70% or something like that very, very quickly. And the team was really confused because all the individual components were fairly reliable, but they were having hours per week, sometimes days per week, where the system was down.
Wow.
And the easiest thing to do in that circumstance was actually to remove components because you can say, well, I need to make all of them more reliable, but then I've got to make 13 components 1% more reliable. That's hard, but it's an instant win by removing 4 of them.
Wow.
And so these are things which come with experience.
I can imagine. Yeah. To have that as an option, right? Because probably the first option, the option that everyone talks about, is to make every component, or the component with the biggest bottleneck, make it more reliable.
Yep.
Right. But to have that outside perspective and be like, listen, this chain of components is not doing us any favors, basically.
Yep.
We need to make that chain smaller, right? Get from the source to where it needs to be faster.
Yep.
And then reduce kind of that risk in between.
Yeah, and we were also having problems with latency and things like that. So this was one of those times where you see there's a solution that solves multiple problems at once. And to be honest, they're the most fun.
Yeah, right.
I mean,
those are the complexities.
Well, yeah, because people say, well, what do you look for? And elegance is what you look for, and that's an example of elegance, where something simple solves multiple problems all at once.
Yeah, I want to get into elegance, but before we do. You mentioned kind of having those discussions where people think they're an expert, right? And I don't think everyone thinks that, but I do see I recognize those situations where people just disagree because of their fundamental understanding, which is different, right?
Huge challenge.
And even when there are multiple options on the table, right? With the 13 components, we can either tackle the biggest issue or reduce the components, right? Those are always options on the table. And no one's going to tell you which option is right versus what is wrong, right? It's always going to be a decision, a discussion, then we commit and we try it out. And we reflect and we see if it's right or wrong. How do you handle those discussions, right? Do you have like a tool for that?
So they are the most difficult ones, because these are people problems.
Yeah.
To be the technical stuff's easy, and these are people problems, which is often in modern engineering, the biggest problems that you're solving are actually people problems.
Yeah.
And so that is a big issue. So first of all, I'm very technically minded, so I will bring technical tools to the table.
Yeah.
Whereby identify where's the problem coming from, because unless you identify the problem, it's hard to fix. It's often in that situation very difficult to tease apart which factors exactly are contributing to it.
Yeah.
But often indeed, it's a fundamental outlook on how not so much how things work, but what you value. It's a difference in value systems. So some people will value the hyper fast, get things working today and fix them tomorrow. Other people value, well, once it's working, I just want it to work on autopilot for the next 10 years.
Yeah.
Recognizing that there's these different value systems driving their points of view is super important. Aligning them can be quite difficult. And I mean, we want to avoid a monoculture of everyone just having the same opinion.
Yeah.
At the same time, so diversity is useful in a discussion. You can bring in extra perspectives and so forth. But there's a bit of a false equivalence at play, because this is going to be a bit political, but not all opinions are equal. Not all opinions are actually grounded in the same evidence or the same fundamental truth behind them. And at the moment, what you often see is everyone thinks, well, my opinion's just as important as yours. And from a emotional point of view and from a people point of view, that may be true, but not always from a accuracy or making a decision point of view.
Yeah.
Now, in a very hierarchical sort of culture where you've got a boss that says their opinion is obviously more important than the people that work for them. Here in the Netherlands, we often have very flat structures.
Yeah.
And also people working for a manager or a boss are normally quite open to telling their boss their opinion.
The real opinion.
Which is refreshing to see.
Yeah.
But sometimes people don't realize that, not all the opinions on the table are actually equal. And I know that's a bit controversial to say.
I mean,
because how do you decide which ones are and which ones aren't? That's a whole different problem. But it's difficult.
I understand what you're saying, but I don't think everyone thinks their opinion matters as much when it comes to kind of those technical decisions, right? Because I've also been in teams where we had to decide, and for example, someone was new or someone thought they had less experience than other people, and they said, I don't feel comfortable to make that decision, right? This is my input.
Yeah.
Like I want it on the table. This is what I think. And then we have that discussion.
And that's good to see because, to be honest, you don't want to be browbeating them or just overriding opinions with power or whatever the case may be.
Yeah.
And that's why I say it's a bit controversial. But sometimes some of the opinions will be better informed and higher quality than others. Mm. And not everyone around the table will recognize that.
Yeah.
And that's normally what leads to tension because if you're right, if someone says, I happen to think this, what do you think? That's different to I don't
my
see,
way or the highway.
Well, or I don't see why we don't just, which is a bit similar to my way or the highway, but a bit more passive aggressive.
Exactly. Yeah. Those are really hard discussions.
Yeah, they are, like. and they're people problems, and they're the hardest ones.
Yeah.
They're the hardest ones to solve. In many ways, these people problems, we think they're new, but they're not.
No.
And in our industry, one of the, I'm not going to say Bibles, but one of the books that people often refer to is the book The Mythical Man-Month, which is a collection of essays.
Yeah.
But if you read it, a lot of those essays are about how you organize people to work together on software. Mm-hmm. And in many ways, they're a reflection of how Fred Brooks in the 70s was trying to solve these problems. So they're not new, but they're
there still.
They're still there.
Yeah.
And I wonder, I think we've gotten a bit better. So when you go back and you read it, you think, okay, with modern eyes, how many of his ideas do you agree with versus disagree? How much of it stood the test of time? And some of the ideas in there, I still think, okay, there's still potential there. We haven't quite exploited that.
Yeah. I feel like as long as we have patience in those discussions and kind of that openness and willingness to learn, because for me, it might be my core value is I have to understand, right? If I disagree with you, then at least I want to understand that why your option is better or why we think that difference is there. And the way to do that is to have patience and to have that discussion in understanding.
Yeah.
And that is from my point of view.
I
from
agree.
The other point of view, there might not be time or I might not be able to understand even.
So this is definitely true. It's also about respect.
Yeah.
So sometimes I will see decisions being made and I don't understand them, but I respect the person and how they've made decisions in the past.
Okay.
So often those two go in hand because respect is something that you build up over time. So there's an issue. You start the door with respect. Sometimes you lose it, but oftentimes, so I need to be able to respect the decision.
Yeah,
is what I often find, and that's often what you see in the smaller close-up situations. It is actually a lack of respect that people have for each other that's leading to the tensions and the problems.
That's a shame. If you allow that other person without understanding to make that decision by virtue of trusting them and respect, if that decision turns out to be wrong, do you then lose trust and respect, or how does that work? Obviously, it depends, but it does kind of contribute to that, I think.
It might. Not after one, right? Because often it's something that's built up and accumulated over time.
Yeah.
And everyone makes mistakes. To be honest, what would make me more concerned about it being wrong was if the lack of reflection. If it's a decision that was made and it was wrong, and they didn't care, that would be a problem.
That's painful.
That would be painful. But if they're like, for example, I had to choose a color for the bike shed. I didn't know that the blue paint's all wrong.
Yeah,
that's fine. That's where maybe understanding helps.
I can imagine. Have you found yourself in those positions as well, where you were the one to make that decision, which in the end turned out to be maybe not the best one, maybe an incorrect one, and how did you handle that?
Definitely, and it's difficult. That's very humbling.
Yeah.
Because you instantly start thinking. Well, at least I instantly go back and think about all the cases where I've had other people do that, and I think, okay, there was a lot more going on that maybe we didn't understand at the time behind these decisions being made. And you're right. Absolutely. Absolutely. Constantly. I've got a current stupid example. I've got a current project where it's a legacy code base. It was developed 3 or 4 half-lives ago in terms of people on the team.
Wow.
And back then the coding style and linting tools and stuff that we used were very different. And so I thought the first thing I'm going to do is I'm just going to bring it up to date. And that's been a colossal waste of time.
I've done that before as well, actually.
Colossal waste of time.
Yeah.
And I shouldn't have done it. Yeah. But, sometimes in the moment you think, yeah, this is the right thing to do. But so constantly mistakes.
Yeah.
Happens.
How did you communicate it in that way to your team as well? Like, this was my intent, and now I realize because of X, Y, and Z that it was a waste of time.
I'll let you know tomorrow.
You still have to do it.
Or maybe when they watch this.
It'll be out next week, actually.
Okay, then I better tell them before then.
That's really funny. Because I really love what you said in the way that people reflect, right? That shows me that they understand what had happened and that they learn and grow from it. Because I don't want someone to not learn and grow from whatever they're doing, right? There's a wasted opportunity, in my opinion.
Yeah, definitely.
Yeah.
Definitely.
So if you make mistakes, then reflect and even communicate that you are aware and you're growing from this and we're learning from this. And it also shows to others that obviously everyone makes mistakes because it's always going to happen, I feel like.
Yep, indeed. It's very frustrating when it happens. Very, very frustrating.
Obviously. Yeah.
But no, absolutely.
Yeah.
100%.
I want to get into back to how things work, because I feel like the knowledge you have kind of compounds, right? If you drill deep down into how things work over and over and over again, I feel like you have kind of this compounded knowledge, which is very valuable in understanding the next thing that comes up.
You're right. Indeed. So the bigger, it's basically your own little private knowledge graph. And the larger it is, or the more diverse it is, the easier it is to hang new ideas and concepts on it. And that means that picking up new technologies becomes, in some ways, easier. Yeah. Because you've seen it before, or you've seen something similar. But in addition to having the knowledge, the real trick is the pattern recognition. Okay. When you see something new, or when you see a concept here, recognizing that it's a parallel to something over there. And taking something from one domain and knowing that it's the same in a different domain. Yeah. And that actually always, that sort of that cross-discipline, I find that super interesting. Yeah, right. Because there's just so much we can learn from how other people do something. An example, I've spent my last few years in the adjacent to machine learning and AI, where we build models and things. And I had a client a few years ago where we were dealing with weather data. And some of the things that weather data and forecasting in particular is one of the original computational use cases for modeling and basically doing inference. Weather forecasting, that's what it is. And they've been doing it since 50s or 60s. Yeah. And you can tell when you work on it that it's a very mature. In some ways, it feels like a different world. But there are certain things and concepts that they use to describe things where I think, hang on a moment, we need that as well. Yeah. Or I need that. I've got that idea and problem. The words that we use to describe things over here, they've got them over there. Wow. And I think, okay, that's super useful. And this happens all the time. Yeah. When you're starting out with programming, people often say you should learn several different languages of different styles, and that's partly to sort of fertilize this ground of how people do things in the idioms in one language, teach you and inform you better about how to do things in another language.
Do you agree with that kind of train of thought? That to go kind of wide and deep at the same time?
Yeah.
Yeah.
Definitely. Sometimes it's really frustrating because you'll arrive on a project with a bunch of people that haven't seen this other language, and you start typing things out, and they're like, "What planet's this guy from?" Everyone's seen, or often you'll see Python being written by C++ academics. It's a very different style. The idioms are different, and so forth. So it's not always good. But at the same time, there will be concepts and ideas that they bring over and that transfer. Which enrich the field.
Interesting. Yeah. For me, it was kind of going back to that compound knowledge that you have in understanding how things work. Because I didn't have a computer science background, I did kind of, it's called business. What was it called? What would I study again? I know it in Dutch.
What's it in Dutch?
Informatiekunde, which is kind of information studies or information science.
It's the art of information.
Exactly. Yeah. And in there, we had like business theory on certain business cases, as well as partly computer science, but it was more so data science.
Yep.
So we did a lot with Python, had to build a web shop as well. So that was like HTML, CSS, but it was more so teach yourself how to do it. With Python, we got more guided lessons in that way. So then I came out of uni and I went into operations because I was like, okay, this is a broad field for me kind of in the tech domain. I can pick and choose what I want to learn, and I still had no clue what I wanted to do. And from there, I grew into the development team over at Nexthill, where we had CBA consultants even. Okay. So their job was to teach me, which was amazing, basically, because it was obvious I had never written production code before. And for them, it was like, okay, well, this is Git. Have you ever used it? Well, no. Well, this is how it works. And this is Go on the back end and Vue on the front end. And that was kind of where my journey started. And because of that, I felt effective, right? Because I was guided, pair programming. I could see what I had to do and I could do it even. But at some point where I had to do it more so on my own or later throughout time, I would think it would be easier or quicker, but then I would fail in kind of delivery speed to myself because it was my own expectations. But then I reflected and I was like, why is that? And I realized that because of that trajectory, because of the on-the-job learning, the practical experience, I had maybe more so a lack of fundamental understanding on a lot of core concepts.
Yeah.
And because of that, I had to backtrack, or I had to Google a lot more. I had to ask more questions because I kind of didn't have that solid foundation that maybe a computer science degree would have, or maybe that some like other theoretical background would kind of give you, or just my path was different than others, maybe even my interests. But I feel like in understanding how things work, that's where it starts, right? A solid foundation, and then you build up from there.
Yes, definitely.
Yeah.
And it's hard. And I believe that in education, this is a big debate. Top down versus bottom up.
Yeah.
Do we start off with the high level concepts and then drill down as necessary, or do we start with the low level concepts and build up? And my own experience there is that the bottom up is incredibly frustrating because when you're doing that, you don't understand where the destination is. Why am I learning all these pointless things? I see that with my kids today in math. They're like, why do I need to learn all these things? Because they don't yet know that these are like the building blocks for later on.
Math is a great example.
Yeah. And so you see some degrees where indeed they start at the high level and then drill down, and others that go from the bottom up. And I don't know which is better.
No.
Because when you start at the bottom up, you'll lose a lot of people because they don't find it interesting.
No.
Whereas if you start at the top, maybe it's more interesting and engaging, and therefore you end up with a bigger group of people. And not all of them will want to drill down, but some of them will.
Yeah.
And which ends up being better, I don't know.
No.
It's I wish I did know that. I don't.
No, I don't think there's a right way in any case, because some people will find kind of that lower level, that deeper level, maybe even as a starting point. I'm not sure. But it is fascinating how things work to start off from kind of bottom up and to build that and kind of compound that into what you see kind of on a higher level.
Yeah. So what I will say is that when you're doing the high level stuff, you can sort of get into a mindset where you think, I don't need to know these details, and I'll drill down when I need them.
That sounds like me sometimes.
Well, sometimes. So it's sort of like on-demand learning, and that can be useful. But I sometimes find myself in that mode, especially when I'm in a domain where I don't fully understand what's going on.
Yeah.
And what I always find is that there reaches a point where I have to say, I need to stop this. I need to spend some time where instead of just doing this ad hoc, I need to actually step back and learn the base, what's underneath.
Yeah.
So that I can then come back to the top level. And that often happens with so at the moment when you're dealing with machine learning and the AI stuff, that happens to me a lot because I don't have the modern background in a lot of the machine learning and data science fields. And so often I find myself working on something and I'm like, do I need to know this? Not yet, but I can feel it coming. And then at some point something breaks or it's not working properly, and then I've got to step back and go, okay, what's it doing?
Yeah.
And then spend a fair amount of time doing that, going a layer deeper. And sometimes it's perfectly fine with that ad hoc learning, because often you don't need to.
Mm-hmm.
Sometimes you can make it through and you're like, okay, move on to the next thing.
Yeah.
Recognizing when it's not quite cutting it right now, that's also important.
I was going to say, for me personally, that's very challenging, because I feel like I'm effective, and then at some point there's a point where I might not be, or I get a different perspective and they're like, well, fundamentally we can do this differently. So the thing we've been compounding on kind of radically needs to change. And then I'm like, okay,
yeah. So
with this understanding, it makes a lot of sense now.
So I liken this to the parallel that I'm going to draw from another area is this is like unit tests and automated testing. It costs a lot of time up front,
yeah,
but every time it pays for itself. And when you work on a code base, if there's not the tests there, you're like, okay, I can adjust it here and there, and I'm pretty sure it's going to work. But then at some point, those changes you're making, you have to test them manually. And then at some point, you're going to say, no, I need to step back, spend some time doing the fundamentals so that I can go faster.
Yeah.
And with this knowledge, it's a similar thing. Recognizing early enough, okay, I'm going to be spending some time here. I do need to go and figure it out.
Yeah, I can imagine. With a new concept, right? And I think it's hard to imagine because of kind of this compounding knowledge, but with a new concept, how would you start kind of figuring things out?
That's a really tough question.
Yeah.
I don't know.
Mm-hmm.
Because it sort of feels automatic and organic how you start off. And it depends on the field. So, for example, if it's a framework, what you're going to do is you're going to look at the examples and you're going to read the documentation. If it's a language, you're going to go through the intro guide. But before you go too far, I'm going to go and read the reference.
Yeah.
That's for those things. If it's more academic, it can be quite hard because you don't know the depths of the ocean that you need to explore.
Yeah.
And I don't have a good answer there. Colleagues are useful though, because hopefully there'll be an expert in the field, and that's luckily something which we've got enough of here. Yeah. And it's been quite. Normally, I can find someone I can say, "Hey, I don't quite get this. Explain it to me like I'm a 5-year-old."
Yeah.
And then we go from there.
Very helpful.
Yep.
Yeah. Is it, from your perspective, I think this is a personal opinion, when you have to go deep, is it also is it an I want to, or sometimes also like I have to? Like is it discipline? I want to. Or like
I'm looking for the excuse. That's me. No, I enjoy that stuff, and I enjoy the low-level details. So for me, it's normally not a huge challenge, except for anything to do with JavaScript. So I don't.
That's the must.
No, that's definitely a must.
Yeah.
No, I enjoy learning about new things. So for me, it's not a challenge.
Yeah.
The challenge is finding the time.
Mm-hmm.
But normally. What I find is that most people are understanding if you take the time, because things afterwards go so much faster.
Yeah, exactly.
And creating the room to do that, sometimes you've got to be a bit, forgiveness is better than permission. Mm-hmm. But until now, it hasn't been a challenge.
Yeah.
At least not that I've heard of.
No. Yeah, I can imagine. I mean, that goes down into kind of how much do you take time to research instead of making the decision and kind of doing the thing, right? Executing it that way and delivering.
Yep.
And I think it's very much having to do with the business that you're in, kind of the phase there as well, and what needs to be done. And if you understand kind of if your own interests align with the business interests as well, that's where you kind of find a stride. But where it conflicts is also where you have conflict.
Yeah, deadlines and competing priorities.
Yeah.
Massive challenge as an industry. We haven't dealt with it.
No. Are we going to, you think?
I don't know. I mean, we're a fairly immature discipline. compared to a lot of the engineering disciplines in particular. They've got a much longer history, some of them longer than others. You could argue that the nuclear industry, for example, is not much older than software, but also spotty record as far as safety goes. So I don't know. A lot of the problems that we deal with are people problems. And what's interesting is if you look at some of the industries where they have solved a lot of problems in a very short amount of time, recognizing the people problems has been a fundamental part of the journey. In particular, if I look at the airline industry and safety, that's, I'm going to say, roughly twice as old as software engineering. But if you look at how they approach problem solving and dealing with issues, I mean, it's about life and safety, so that tends to focus minds. A lot of what they do is about recognizing that people are human and how to cope with that. Whereas in software, we haven't quite gotten that far. The other thing that makes our industry a little bit different is that a lot of the time when we're building something, the reason we're building it is because it hasn't been done before. If it's been done before, someone's turned it into a product or a library and we're buying it most of the time. And so that means that solving the problems of how long things are going to take and all of these people issues, I don't know how easy it is to solve. If you're building houses or something, right, not every house is the same, but a lot of them are very similar. But if you look at the effort that goes into planning a house that's architected, that's a lot more than that goes into something which is just being copied over and over again. That's as close as I can get to sort of examples where people may have solved these issues in other areas.
I love that example. Because in software we do build kind of similar things, some more well architected than others in that way.
And it's tricky. So most of the projects that we're working on should be closer to an architected building, which is a one-off versus a cookie cutter design, bought off a plan or something like that. So what I wanted to mention is that what also makes software different is that we haven't yet figured out the integration complexity. So when I look at these other industries, they've got standard solutions for how you combine the components and things. So if you're a builder, the way joints are made and the way the different independent systems interact is standardized. We don't have that in software. And sometimes you work on a project where you're building from scratch. It doesn't actually exist anymore, but let's say we've got one end of the extreme where you're building from scratch, another where you're taking 5 or 10 existing things and basically mashing them together. Pure integration versus development. Often in our industry at the moment, the complexity of that integration can exceed building it yourself. And that complexity of integration is a huge challenge. All the big software projects that we hear about failing are typically integration-related efforts.
Interesting.
They're not building these systems from scratch, and we brings the loop kind of around because is it a people problem that led to this integration failure? But that's something that struck me, and I don't know what the solution is.
No, I'm not sure if I've realized that actually. That those are kind of two extreme ends, but they are kind of, I do recognize them in previous projects.
So nothing is from scratch in isolation anymore. Once upon a time you could wire wrap a CPU together. That's from scratch, close. Whereas these days everything is using existing components and libraries. What you get these days, even 15 or 20 years ago with the Java runtime library, that was a massive step forward compared to what everyone had in the 90s, where people would build their own hash tables and things because that didn't exist. Whereas these days, who thinks about that? So,
in that way, we do have kind of standardized, like it's a combination, I guess.
Yep.
Some stuff is standardized and some stuff is still custom, and if we integrate that, that is where the complexity is.
Yes.
Yeah.
Yeah, definitely.
Yeah, I can imagine.
So the challenge, I mean, we're seeing this play out again now with the modern microservices-based architectures, and that's sort of replacing everyone trying to do it in one big monolith, but it's still it's still an integration challenge.
Yeah, exactly. I want to, because as kind of a final topic, you mentioned elegance before in this conversation and in previous conversations as well. To start off, kind of what defines elegance to you? Because I feel like the people I've talked to, they make it very subjective, and it's sometimes very hard to pinpoint then what it means as kind of an overarching topic.
I can describe some of its properties, but that's not necessarily fully descriptive.
But that makes it easier, I think.
Yeah, so some of the properties, when you see something that's elegant, it's something that's obvious once you've seen it, but before you saw it, it may not have occurred to you. So there's an asymmetry to when you've seen it versus when you haven't. It also tends to be something which solves multiple competing concerns at the same time.
Yeah.
And it tends to be simpler than the problem it was solving.
Okay. So it removes the complexity.
Something that in one step eliminates complexity and solves multiple competing constraints. So the way I'm a fairly visual person, but the way I visualize a lot of these constraints is you're trying to find a path around the boundaries of what the constraints impose.
Yeah.
And sometimes you'll end up with lots of things all sort of converging on a single point, and that point is where the elegant solution might lie. That's a very abstract way of putting it, but for example, there's a snippet of code which someone once posted to do with how I think it was a Google engineer came up with a persistent hashing algorithm, and it was only 3 or 4 terms. It was certainly less than a line, but it solved so many problems to do with persistent hashing. So persistent hashing is where you need to divide data up over roughly equal compartments, and that equal compartments has to remain equal irrespective of the distribution of your data.
Okay.
So it tends to be hashing of some sort. And one of the challenges is what happens when I want to change the size, the number of compartments. And a property that you want is that things don't move unnecessarily between compartments. And this algorithm had the property that it solved that problem. And it's elegant because it takes an area of math and it applies it to this problem. And people had spent all sorts of time trying to figure out other ways of solving this. And you just think in one fell swoop, they've solved it. There's also a similar, there was also a Python example where I think it was in 10 or 20 lines of code, you had the essence of Google search or something. Yeah. Similar idea where you think someone's managed to find something that's very simple that just solves a very wide range of problems.
Would you say those solutions are, like, would you call them clever or smart? Because sometimes I see a solution, I have to drill very deep into kind of how it works. And then I'm like, okay, this is smart, but this could still be simpler. Like, this is the smarter solution, let's say. It's the same as if I, especially with Python code, if I do everything in a one line versus kind of writing it out and making it more readable.
That's a whole different topic. But I will say it needs to be understandable. I think that's where I stand on that.
Yeah.
Because occasionally you'll see very dense solutions.
Yeah.
And they appear compact, but they're not necessarily elegant because I think you need to recognize it. And that's annoying because it means I can't make something elegant. Other people have to judge it as elegant.
Yeah.
And yeah, so yeah, I don't really, yeah, it's hard to describe.
I can imagine. Yeah.
Yes, sorry.
And in kind of your day-to-day work, right, how much of it would you say is kind of, that is elegant code or elegant output in what you're creating? And how much of it is kind of...
Less than I'd like.
Less than you'd like.
Well, the thing about elegance is that it doesn't always come to you in a light bulb moment.
Yeah.
You've often got to spend some time exploring the space, and you don't always have time to do that. I'd like things to end up elegant, but I don't always have the time.
How is accepting that?
Actually, that sound was the perfect description.
That's how it is.
That's how it is. Like,
Yeah.
no, indeed, you just have to accept it.
Yeah.
Because we don't always have the time, and it also takes a while to accept that not a messy problem doesn't always have a clean solution. Sometimes the solution to a messy problem is a messy solution, and you just can't get around that.
Yeah.
We're used to in high school when we're doing math, they make the examples that you have to do, they make them so that the working out is nice and easy to follow and you end up with a simple answer.
Yeah.
The real world's not always like that.
Absolutely not.
And recognizing that I'm not always going to get a clean answer from when I have to solve a math problem, it's the same in this area. And sometimes you just got to say, well,
that's it.
That's it.
Yeah, I get that. In kind of visualizing, you mentioned that kind of you were drawing out, for me at least, multiple lines, and when there was a converging point, that might also be where most complexity would be, and where an elegant solution might be most effective.
Mm-hmm.
Do you take time in kind of being like, okay, these are critical decision points we have to make. These decisions and kind of the solution for that might need to be more elegant than, let's say, the messy solutions we have elsewhere, just because of the factors involved, the risk there, or the value to be had even.
Don't know.
That was very abstract, I know.
No, it is, but I haven't really thought about it.
Yeah.
And that's a tough one.
Yeah.
I don't really have an opinion on that yet. What I will say though is that sometimes it sounds counterintuitive, but sometimes you do want to back off from the oversimplified and elegant solution.
Okay.
Sometimes that can make things harder for yourself.
Yeah.
Just because of other people being able to understand it and follow it and change it and modify it. That's just that's a hard thing to explain. But
no, I understand, because for me, especially at those points, right, where I feel like this is a crucial decision, I don't want any unnecessary complexity in a solution we're creating. Right.
Yeah.
I want things simple. I want it to be able to be understood by the team, basically. Because if we don't understand this crucial part, I see it as kind of a foundation in knowledge in the thing we're going to build on top of.
Yeah. So if in that particular situation, indeed, you're talking about, I've got a solution to a problem.
Yeah.
It needs to be understandable to me, but more importantly, it needs to be understandable to the team. And the third thing is that it needs to be resistant to changes in the wrong way.
That's the thing.
So you want to make sure that whoever comes along next, you want to make it easy for them to modify in the right ways. And that's hard, because what's the right way?
Yeah.
You don't know that yet. But you do want to make sure that they're not going to accidentally make a change that breaks it.
Mm-hmm.
And sometimes that means your small, simple solution needs to become a little bit more elaborate with checks and defensive mechanisms around it and tests and things, just to forego the possibility that someone will accidentally break it.
Yeah.
And that in some ways is less elegant, but it's a practical sort of thing that you need to do. Because, I mean, if something looks innocent, it's very easy to accidentally break it.
Yeah.
I've done that many times.
That's I think that's a great perspective to have. One I hadn't thought about as much yet, but I do see that.
Also, we joke when we're writing code about who's the audience, right? And there's several audiences. The first is obviously the compiler. It has to be correct for that. We focus on that. We also talk about our teammates and reviewers. That these days is often the bottleneck in code going to production. The review and process of your teammates also understanding it. So the second audience is your teammates, but there's also a third one, and that is future you or teammates need to also be need to be able to understand it, understand what you were concerned about versus what you were not concerned about, so that they can safely make changes without breaking everything.
Yeah.
And those additional audiences, when you're writing code, they're not always obvious.
No.
At first, you're mostly focused on making it work.
Yeah. I mean, more and more as I've grown, let's say more senior into kind of this role in creating software, that last audience for me has gotten significantly more important because I try and fit in as much context with my commit messages. Specifically, they have a format, they have a convention even. The references to whatever Jira and context that was in there is also going to be in there. The pull requests are in there. I try and pay more attention to that, like way more attention to that than very early on code. Because I know that I'm going to look at this. Other people are going to look at this, and I might not even be there anymore. And even when they are gone, more people are going to look at this. So as much context as I can give them to kind of help them along the way, I think that's very important for kind of the longevity of the system and the changes that are going to iterate and compound over time.
Yep. You can judge it. You can see it instantly when you look at code by how many comments there are and what their style is. At some point, you'll start seeing and creating little essays all over the place that explain, I was here, these are what I found, the code assumes this, I chose this because of this, this, and this. That's why it works this way. You end up with these little essays sprinkled through the code at some point. And then, 2 years later, you come back and you're like, okay, thank you, past me.
Yeah, I got this now. On that note, this was a blast, Andrew.
Okay.
This was a lot of fun.
Indeed. Thank you very much.
Thank you as well. In kind of laying out how things work as well as elegance, is there anything that was missing that you still wanted to add before we round off?
Not really. We've covered quite a bit. So I don't think anything springs to mind.
Cool.
You've led me through the various things.
You've helped me a lot as well, though.
Fairly well. There are lots of little anecdotes where I think, I missed that anecdote or missed that little anecdote, but I'm perfectly fine with that.
Awesome. Cool. Then I'm going to round it off here, everyone. Thank you so much for listening. I'm going to put all Andrew's socials in the description below. Reach out to him. Let him know you came from our show. And with that being said, thank you for listening. We'll see you on the next one.